Actually, the that solar cell will not produce that much energy that we are required for the using for the applications. Actually, that solar silicon cell will provide like zero point 0.5 watt and zero point 0.6 watt power. Only it is having 6 inches square, and it is some solar cells will produce 1 to 2 watts. So to increase that generation capacity, so we combine all silicon cells together that will form a solar module or panel. So for that solar module panel, it is like it is combined solar cells with copper bus. Every solar cells is connected one to one with solar copper bus, and also that all solar cells will be solar cell power generation will be done by the silicon bus. There is a one silicon bus will be there. And solar PV models usually, in case with like I said earlier, like it is having non-reflective glass, because that non-reflective glass are a plastic that you can use to protect from the weather as well as the rains, and also we can get the maximum power from the sunlight, because that we can get the sunlight 100% light. We are not going to produce the 100% energy. We are only use generate like 13 to 24%. When remaining energy will use for the drive the electricity field, and for the PN junctions, and also some go to the sun. It will reflect and it will go to this side, and some diffused it will go to this earth surface. So we are receiving 100% solar sun's light. We will produce only 13 to 25%. And multiple solar PV modules connected, like I said, that form the solar panel. Then we can connect it one by one solar modules that we can call this array, and that multiple arrays will connected in series or parallel, we can call as string. In that case, we can connect the PV modules in series. So it will increase the voltage. Like we are having 2 volt solar panels. We connected in series. Like 4 panels were connected in series, and it is having 4 amps current and 2 volts voltage. So we connected 4 modules like 2 plus 2 plus 2 plus 2, like 8 volts. We will connect it in series. And when connected in parallel, it is a 2 volts system. It is connected, and 4 amperes current. In parallel, like we can get the current will be the increase like 16 amps. 60, that is 32 amps, sorry, like 4 panels. And we will go for the this type of panels like monocrystalline, polycrystalline PV model, and thin film solar models. These three are widely used in the solar systems, and most probably polycrystalline PVA model is contributing more than 60%, and remaining monocrystalline and thin film PVA models will not use that much, because that monocrystalline PV model is very expensive, and thin film solar PV model is very sensitive in use, and also it is having less efficiency. So we can see this in this picture. We can see the solar cell, how it is solar cell, and that connecting every solar cell into the solar module, and solar module will connected as a solar array, and that solar array will connected through the balance of systems, and like it is developing more tracking system, mounting, and it is having a combiner box and monitoring box and battery for the storage, and inverters that will convert DC into AC. And after that it will go to the isolator or switch gear, and in switch gear, from there you can connect to the direct to the grid. In between switchgear and grid, we are having net metering for this, like how much power generation we are generated, and what is the import means how much generation we are given to the grid, and export means how much supply we are taken from the grid. So basically, like I said, monocrystalline solar power cell it is a pure silicon. It is having purity of 80%. It is having more efficiency than the other polycrystalline thin film. So it is because of this silicon is very expensive item. So because of that one, and you are using the purity of 80%, this is very efficient also, and very expensive. And most probably monocrystalline will use for the small applications like rooftop and off-grid systems for the oil and gas. And it is having efficiencies of 16 to 21%. Now nowadays they are developing stages will be now it is reached to 34%. It is not come to the commercial operations, but there is some developments going on with monocrystalline. It will having efficiency up to 34%. Bolacrystal in it is appearing in black or in dark blue color. You can see the model. We can easily identify the what is the monocrystalline, what is the PB crystalline, and also thin film. This as compared to these polycrystalline and monocrystalline, thin film cell is very thin than these two. And polycrystalline solar PV models are made with polycrystalline, it is having multi-crystalline silicons, and it is having purity of 30%, and it is not that much efficient as the monocrystalline, and it is having 15 to 17%. And it is also developing some of the technology and increasing that efficiency up to 25%. And some of are in the operational. Generally, it will produce 15 to 17%. We are go for the high quality modules, so it will reach up to 25%, and that cost also very expensive. And these polycrystalline solar modules are widely used in power generation plants, because it is in the reasonable rates. So in nowadays in India, per unit like kilowatt hour cost, it is comes around 1.9 in the 2020. Now once again, due to the recession, it will now once again increasing like 2.5 to 3.2. So these are the very economical and sustainable polycrystalline. So these will use for widely used in the solar power plants. Thin film PV module, it is like less cost, because we are using only 16 to 10% silicon, and other materials you can use for this create the solar cell and modules. So it is having less efficiency than the PV crystalline and monocrystalline. It is also efficiency having 13 to 20%, but it is not that much efficient as compared to the uh, polycrystalline and the monocrystalline. And it is having like very thin in the very thin, like it is like glass type material. You can see in gray, brown, or black. It is up to like, and in polycrystal, it most probably appears in the blue. And we can see the multi-crystal. We can see in the light in the sunlight surface. You can see the signs of multi-crystalline shines in the polycrystal. So we'll go for the solar PV system and types. And this is PV system is basically this is you can give the idea about this. What is the solar PV system? So this is actually it is on-grid system, and also it is having energy storage. So it is called hybrid energy system at the solar PV system. So first that generation will come once, like in usually solar panels will generate the power from the 6 p.m. to evening 5:30 6 p.m. It depends upon the season. In winter season, there is a day will be less, and summer season that day will be high, that is 6 to 8 p.m. evening 8 p.m. So it will varies depends upon the season. So it will generate the generally from morning 6 to like you can say that sunrise to sunset. In night time, there is no power generation from the solar panels because it will not generate a power. But recently in Australia, there is one experiment has done successfully that solar panels, which is used for which is generating power in night itself. So that is in the development stage. So it will that technology will come later. That basically that solar panels will connect to the DC AC inverters. That is inverter will convert that DC into AC, and that will transfer to AC distribution box. That is, we can call the fuse box. So from there you can connect like TV and LED bulbs and the tube lights, anything. And it will inverter will connect to the battery, and it will also that excess power generation will store at the battery, and once it will sunset, and it that power electricity will come from the battery to inverter. Once again that converted into AC, then you can use for the home appliances. So in on-grid system, it is only off-grid. In on-grid system, only difference is on-grid system will connect it to the electricity power lines, and off-grid system it will use for only that home itself. It will not give the any generation and any power to the electricity department. So in that one, in between that grid and electric solar PV system, there is a one net metering that will calculate the import and exporting of the units, that generation units. So this is the basic idea about the solar PV system. So like I said, in residential, commercial, and industrial, we are having three types of solar PV systems. That is off-grid solar PV system, and on-grid PV system, and hybrid PV system. And this is off-grid PV system. It is basically like I said, it is not will not connected to the grid. It is only connected to the battery energy storage. So it will generate the power from the modules, and it will convert that DC into AC and use for the utilization appliances like TV and bulbs. And after using that one, we are having excessive energy that will store into the battery, and also some other systems like it will directly connect to the from modules to battery to the inverter. That means the solar energy direct go to the battery system, and it will store there, and it will give to the inverter, and you can use from the inverter to the AC box, AC distribution box. And in on-grid power system, only difference is it will connect to the grid, as well as it is not having the battery system. Like I can, yeah, this is the off-grid solar system. The solar panels will come to the inverter, and inverter will convert that into the AC, and the AC will go to the fuse box or circuit breaker or the AC distribution board, and that will distribute the all the power to the home appliances. And this is the only system in off grid, and you don't have any net meter and any connection to the grid. And we come to the on grid. It is the same similar like and it is having battery system also in the off grid, but it is not showing here. But off grid has having battery energy system, so we can store the excessive energy in the batteries, so we can use that in night time. In on grid system, it is connected to the grid. In between, we don't use any batteries for the storage. Only it will direct that we will use for home appliances. Any excessive energy will go to the grid. And in night time, we will get the power from the there is no generation from the solar panels. So in the during the night times and in any abnormal conditions like rainy seasons, so we will get the generate electricity from the grid through net meter. So in that net meter, we can having the import export details, so that every month bill will be generated. So in hybrid system, it is basically connected to the grid as well as the battery system. So it can use for both off grid, on grid also. So it is the same thing, and only a battery system and grid system is there. So is there? You can use any kind of conditions. You can use this one is very effectively, but as compared to on grid system, that off grid system is very expensive due to the battery storage, but the batteries are very expensive. And also this hybrid system also very expensive, but because we are using different kind of the inverter also very expensive, because this is a hybrid. So we have to get from the main grid as well as the solar panels. So for that one, you need to operate two dual systems. So that inverter also very expensive and battery bank also very expensive one. So hand grid is very that much expensive as compared to the off grid and hybrid, because it is not using any storage devices like batteries. So and another one is the ground mounted solar systems. Basically, it is used for the large scale utility, like you can use for the villages, like 10,000 villages, 40,000 villages, like that one. So it is basically it is similar to the on-grid system, and it is having equipment is range is different, but the phenomena is the same. That solar panels will generate the generation, and it will go to the grid inverter. Sometimes we can use in between solar panels and inverters. We are using combining box or string combiner box or string monitoring unit, so that you can track the each and every string from the solar panels and solar arrays. So that inverter will convert that DC into AC. It will connect it to the transformer, and transformer will convert, because this solar panels produce only low voltages, like it is range from the 400 to 800 voltage, 800 volts, and that will not use for the grid system having the nominal voltage like 11 kV, 33 kV, 66 kV. For that one, we need to step up the voltage level. So for that one, you are using transformer. From that transformers, you are using that you can step up the voltages, and that voltage will connect to the grid. In between grid and transformer, there is a switchgear will be available for the protection purpose, and also controlling purpose. And also we are having in net metering, so that we can get the import export details from there, and we will provide we will and in this system we are having a power purchase agreement with the developing developers, like some investors. We are They are they will get the power from our plants, like discoms, electricity departments in all the states, and also some REC, rural electrification department will give the investment for this one. So for that one, we need to generate every month raise the invoices for the concerned PPA department, so that we can get the that generation units cost in that one gradually. That return of investment for this ground mounted system is 5 years, because in India we don't have a VGF, like value gap funding for the investments, and that means that we can get the return of investment of the all these ground mounted system in the 5 years. And we basically and generally we are having a power purchase agreement for the 25 years. So it is operational cost also very low. You can say that we are having a power purchase agreement for the this particular plant, like 2.2 paise, 2 rupees per kilowatt hour. So that maintenance cost will be the very less compared to this one. This is like zero point 0.2 to zero point 0.5 kilowatt hour. So as compared to like fossil fuel power plants, like thermal power plant, it is having less maintenance, and we can monitor and control the system through SCADA in the power plant. So we can check the any problems in occurs in the solar panels or strings, and also in the inverter or any transformer having any issues. So we can check everything from the main control room itself. So in that ground mounted system, there is a four kind of PV systems available in the ground mounted systems. Like it is a fixed tilt solar PV system, and seasonal tilt for a solar PV system, and single axis track solar PV system, and dual axis solar PV system. So there is no difference in operation for these four types of solar PV systems, only to get the efficiency better than the other systems. Like in fixed tilt solar system, we are using only one angle. Like these modules, these panels will be installed in only one tilt angle. Like you can say it is 20 degrees angle. So every system will be done in that angle itself. So it is done by the steel structure, like you can call it as module mounting structure, that is in short form MMS. So from that one we can connect these all panels, above panels in one string, and below it is a two-piece system. It is called 2L system, two-piece system, like one in top, one in bottom. So top modules will connect to the one string, and the bottom will connect to the another string. So these will come connected to the string monitor box or string combiner box, and from there there it will connect to this inverter. Like same similar to the this one, there is no difference. Come to the seasonal tilt solar PV system. It is actually tilt system will varies from season, like winter season, summer season will change. Like we are for example, we are done this one in the 13 degrees true south for the summer. So we can change that to the 45 degrees for the winter. Like example, we can change this angle for the every season. So we will change every structure of the system, and that efficiency as compared to fixed tilt, it will be it is having more efficient than this one seasonal tilt. Because we change the angle, tilt angle, so that we can get the more energy from the solar light. Like I said in the earlier, that solar light will strike the panels in the particular, then only you can get the maximum efficiency. So if it is not perpendicular, so it will not get that much efficiency. So for that, getting more efficiency, more energy, so we will change the angles, tilt angles for the every season. This is seasonal tilt. This is single axis solar system. It will rotate along with the sun, from sun rise to sunset. So it will rotate from 0 to 90 degrees and 0 to 180 degrees. So as well as for the our requirement, you can connect that all systems will connected for one motor system. It will rotate from sunset to sorry, sunrise to sunset, so that we can get maximum energy for that one. Like if like uh, you can say in the early in the morning, it is in the like 5 degrees. So it will change by mid by afternoon. It will go to the like say 50 degrees, 55 degrees, so that we can directly gain the sunlight perpendicularly to the panels. It is also very efficient compared to the seasonal tilt, because seasonal tilt only do for the seasonal, like every 4 months, every 3 months. For this single axis tracker, it will done for the every day. It will automatically rotate from 0 to 180 degrees. And dual axis system tracker system is also same thing. These systems and these technologies is developed to get the maximum efficiency for the solar PV plants. And then operation will be the same for the every PV system, but these technologies will develop for the get the maximum efficiency. That is only reason with this, that these are also very expensive as compared to the ground mounted. These are the very less contribution into the power generation. These are like 10 to 20% contribution as compared to ground mounted fixed tilt. It is having more than 60% contribution in the electrical generation plants. Because it is very expensive, like have to provide the piping system and motor systems for the every single table track. It is dual axis means that you can move solar panel in any direction, like 0 to 360 degrees. We can move that solar table panel. We can move 0 to 360 degrees as per the our design that provided that particular geographic locations. We can move anywhere so that we can get the sunlight direct to the panel perpendicular, so we can get maximum energy and we can get maximum efficiency from plant. And floating solar PV system is basically it is also one of kind of a solar PV system, because we are using more land for the ground mounted. So I think in future, like in 1 to 5 years, we don't have that much land for the uh, construct the solar PV system. So we are using floating solar PV technology. That is basically, it is operation will be the same, but it is having more efficient than the that system, because it is in the river or water surfaces. So it is having more efficient, because mainly to the these systems having soil having more less efficient, because it is having dust will be formed on the solar panels. That is the main reason it is less efficient than the floating solar. Floating solar are having much efficient than the ground mounted solar, but it is very expensive PV system as compared to ground mounted, because it is having a separate system, like it is a very complex system, like marine bottom anchoring, or also like bank anchoring for this because that in rivers water will flow, but then that it will not same constantly, water will not like on the same level, so it will vary from the different reasons. So for that one, we can adjust this floating system to like in nowadays we can adjust water levels will be different, like in summer season water level will be low, and in rainy season water will be high. So we can adjust this floating system for 2 meters. As per now technologies, we can adjust this floating system up to 2 meters using mooring lines will connect to the bottom anchoring, or also bank anchoring. So we can adjust from there. It is basically that bottom anchoring and mooring system. It is basically this offshore system. So anyone having idea like in offshore systems, they can get clear idea about this moorings anchoring. And this is having the like having same similar floating system for the transformers and cables, floating system for the cables, so we can lie floating system on the top, and using HDPE floating systems. We called it as floaters. Floaters, so we can adjust from this one. So this is one complete is complete power system floating power station. It is like 10 megawatt floating power station, and in between this is a there is a wide this is called walkways. So we can in these walkways you are using a small boat to reach this one walkways, and we will say inspect the all these systems, it is working or not, is there any issues that we can know. That white system is walkways, as well as the in between there is a inverters also installed in that one. That black is the inverters. And another, these are the cables. It is in last bottom. There is a one cable floating system will be, you can see. And basically, for the floating system, substation or the cooling substation will be done at the ground itself. But because it is very difficult on the floating, that entire substation will not be done in the floating system. So 95% substations or any switchgear main control rooms will be done on the onshore, like ground, and the remaining solar panels and inverters will be transformers are in the river side and floating side. So this is the base idea about the solar energy and that types of solar energy and solar PV system and its types.